12.2 talks about arithmetic sequence. So a sequence of the form, you take a term, add a number, and add the same number again and again. So the difference between any two consecutive terms is that d that you add is called an arithmetic sequence, where a sub 1 is the first term on the list and d is the common difference. You find this d, what you're adding, by taking any term subtracted from the previous term. The general term, and remember, general terms generate the entire sequence, is given by the very first term plus n minus 1 times the common difference. We touched on that in the last section. We kind of did it brute force, but that's what it is. So to find the general term of any arithmetic sequence, you need the first term and the common difference. And that's pretty much it. So look in here. The general term of an arithmetic sequence is given. Find the first four terms and the common difference. Well, the first term is what? Replace n by 1. That's a 0. That's negative 3. A sub 2. Replace n by a 2. 2 minus 1 is 1, so that will be negative 3 plus 5 times 1, which is 2. A sub 3 will be, put a 3 in there. 3 minus 2 is 1, 3 minus 1 is 2. That will be negative 3 plus 5 times 2. 10 minus 3 is a 7. And the fourth, well, you could tell, you went from negative 3 to 2, you added a 5, it's right there. You added another 5, the next term will be a 12. And the common difference would be a 5 in this case. Take any term minus the previous term. And it doesn't matter which of those you take. So looking at B, same deal. A sub 1 would be, put a 1 in there, that's a 0. So that's 2 minus 0, which is 2. The second term, this will be a 2. 2 minus 1 is 1, so that's 2 minus 3, which is a negative 1. A sub 3 would be 2 minus, put a 3 in there, 3 minus 1 is 2. That will be 2 minus 6, which is a negative 4. And you could tell what you did, you added a negative 3 to each of those. So a sub 4 would be a negative 7, and the common difference would be any term, say the second minus the first, which is a negative 3. And if I look at C, a sub 1 will be, if I put a 1 in there, that will be a 0. A sub 2 will be, put a 2 in there. 2 minus 1 is 1 times 1/3, that's 1/3. A sub 3 will be, put a 3 right there, that will be 1/3. 3 minus 1 is 2, that's 2/3. A sub 4 will be, well, let's see, since they told us it's arithmetic, what do you add to 0 to get 1/3? 1/3 plus another third, that's 2/3, plus another 1/3, that is 3/3 or 1. And the common difference is, take any term minus the previous term. There it is. So, the first four terms of a sequence are provided. Here, they didn't tell us it's arithmetic. They're saying, if it is arithmetic, find the common difference. Well, let's see. If it is arithmetic, start with D. Take 5 minus 3, which is a 2. And C. If I add 2 to 3, I get a 5. I add 2 to 5, I get a 7. Yep, it does look arithmetic, and D equal 2. That does check. That's all they want. How about here? If I take D, I'll say that's any term minus the previous term. So that is, if this is arithmetic, D should be a 4. Let's see, if you add a 4 to negative 10, that's negative 6. Add another negative 4. Yep, add another 4. And there it is. So if you leave it as a D, you're telling me it's arithmetic. Here, if I take any term and subtract it from the previous term, remember how logs work. That's natural log, and you divide 6 over 3, which is natural log of 2. So you're adding natural log of 2 every time. If I add natural log of 2 to natural log of 6, natural log of 6 plus natural log of 2, that's natural log, and don't you end up multiplying those? That's natural log of 12. It works. And if you take natural log of 12 and add natural log of 2 to it, that's natural log, and you multiply 2 times 12, which is 24. So yes, it is, and there's my D. And if it's not, you just say it's not. That's the end of it. List the first 4 terms of the sequence, determines if it's arithmetic. If it's arithmetic, find the common difference and write it in general term. Well, let's see. First 4 terms. A sub 1. If you put a 1 in there, 1 plus 3 is 4. A sub 2. Add 2 in there, that's 9 plus 1, that is 10. A sub 3. I should write that down for your notes. A sub 3. 1 plus 3 cubed, which is 28. Well, obviously it's not arithmetic. They said to list the first 4 terms. Let me list another term. A sub 4. 1 plus 3 to the 4th, that is 82. So obviously, if I say D equal 10 minus 4, which is 6, add 6 to 10, you don't get 18, so it's not arithmetic. And if it's not, I don't have to do much work for it. How about here? A sub 1, put a 1 in there. Negative 3 minus 1 is negative 4. A sub 2, put a 1 in there. Negative 3 plus 1 is negative 2. A sub 3, put a negative 1 in there. Negative 3 minus 1 is negative 4. And A sub 4 is negative 2. So again, it's not arithmetic. Because I know it's not going to work that way. Oh, wait. No. Put negative 4, negative 2, then negative 4 back. That doesn't work. How about here? Third example, if I list the first 4 terms, well, A sub 1 is 3 plus 2, which is a 5. A sub 2 is 3 plus 4. That's a 7. A sub 3 is 3 plus 6. That's a 9. A sub 4 is 3 plus 8. That is an 11. So you're adding 2 every time. That works. But I need it in this form. A sub n is the very first term, which is a 5 plus n minus 1 times the common difference, which is a 2. If you simplify it, of course you're going to get that. Given an arithmetic sequence, they're telling us that this is an arithmetic sequence. Determine the common difference. Well, the common difference, I'll take any term minus the previous. If they tell me it's an arithmetic sequence, I don't have to check. Find the nth term. The first term plus n minus 1 times the common difference. The nth term is the first term plus, the first term was a 2 plus n minus 1. The common difference is a 5. You could simplify it. You could leave it like that. I don't care. It's up to you. And find the 100th term. The 100th term will be 2 plus, if you put a 100 there, that's 99 times 5. So the 100th term will be, what is that? 545. $497. That is the 100th term. And how about if I look at the next term, the next sequence? They're telling me this is arithmetic. Take any term minus the previous term. The general term. The first term, I suggest you write it every time until you memorize it. The first term is x minus 2 plus n minus 1 times the common difference. Got it. The 100th term, a sub 100 is going to be x minus 2 plus, if you put 100 there, that's 99 times negative 4. So a sub 100 is going to be x minus 2 minus 4 times 9 is 36. So a sub 100 is going to be x minus 398. So once you get the hang of what this is, it's not that bad. You just need to know two formulas for arithmetic. Actually, you need to know one. I provide the second. Now, find the indicated term of an arithmetic sequence. Find the 20th term. I'm sorry, the 20th term is 130. So we know that a sub n is a sub 1 plus n minus 1 times the common difference. A sub 20 is a sub 1 plus 19 times d, and that is 130. That's one equation. They tell me the common difference is a negative 5. If they tell me the common difference is a negative 5, doesn't that mean that a sub 1 plus 19 times negative 5 equal 130? A sub 1 minus 45. So a sub 1 equal 130 plus 95. What is that? 130 plus 95. 225. So the general term is 225 plus n minus 1, and they told me the common difference is a negative 5. I need the general term to find any term, or to do pretty much almost anything with an arithmetic sequence. They either ask for a specific term, or they give me a term, I replace a sub n by it and tell them where is it on the list. Find the 11th term. That's 225 plus 11 minus 1 is 10. So a sub 11 is 225 minus 50. The 11th term is 175. The 10th term of an arithmetic sequence, that's a sub 1 plus 9 times d, is 80. And the 6th term is a sub 1 plus 1 less than 6 is 5d, is 104. Find the nth term. Well, I need the first term and d. That's kind of like saying x plus 9y equal 80 and x plus 5y equal 104, right? So if I multiply the top equation by a negative, that becomes negative a1, negative 9d equal negative 80. Add negative 4d equal, is that 40? No, not 44, 24. 80, yeah, 24. Divide by negative 4, so d is negative 6. Pick either equation, let's say that one. A sub 1 plus 5 times negative 6 equal 104. A sub 1 minus 30 equal 104. So a sub 1 equal 134. So the general term of the sequence is the first term plus n minus 1 times the common difference. The first term is 134 plus n minus 1 times a negative 6. You could simplify, meaning you distribute the negative n if you want. And you could say the general term is 140 minus 6n. To me, it doesn't matter. Those two are saying the same thing. Either way, it's fine with me. Now, if you happen to want to add the first term plus the second term plus the third term all the way to the nth term in an arithmetic sequence, I like to use this a lot more than this. That turns out to be, and I like to write it, that's how they write it in the book. I like to write it as n over 2 times the first term plus the last term. So take the first plus the last term and multiply that by half of the number of terms. And that formula is provided on your exam, so you don't have to memorize it, you could just use it. And if we look at this, find the partial sum of an arithmetic sequence that satisfies the given condition. Find the sum of the first 40 terms. So I have a 5, negative 3, negative 1, 5, 3, 1, negative 1, negative 3, negative 5, negative 7, all the way up. And I want to add them up. So, the way it works, S sub 40, which is the sum from n equal 1 to 40 of a sub n is n over 2 times a sub 1 plus a sub n divided by 2, or it is n over 2 times twice a sub 1 plus n minus 1 times d. So in this case, what do you notice? Based on the information they gave me, to use this, I need the general term. But here, if I use this form, that would be 40 divided by 2 times twice a sub 1. We know a sub 1 is 5. Plus n minus 1, 39, times the common difference, which is a negative 2. And there it is. That is 20 order of operations. That is a 10. That is a negative 30. That's a negative, what is that? 1878. So that's negative 68. And that sum will be a negative 1360. Of course, you could use a calculator for that. No need to do that by hand. Same deal here. If they told me a sub 1 is negative 10, a sub 5 is negative 2, and n equal 100, well, I will have to do either one of two things. If I want to add the first 100 terms, that is the sum from n equal 1 to 100 of a sub n, that is n over 2 into a sub 1 plus a sub n, or that is n over 2 into twice a sub 1 plus n minus 1 times d. And they get this formula, by the way, by replacing this by a sub 1 plus n minus 1 times d. And they combine them. Not a big secret. So either way, well, let's see. We know the first term. In both of those, we know the first term. We know n. The thing missing, here we need a d, and here we need a sub 100. So it's up to you. Well, if I know that a sub 5 is a sub 1 plus 4 n minus 1 times d, and that is a negative 2. A sub 1 I already know. So isn't it easier just to solve for d? For d equal 8, d equal 2. So I could say s sub 100 is 100 divided by 2, twice a sub 1, plus n minus 1, which is 99 times 2. That's one way. You could work that out. Or you could say, you know what? S sub 100 equal n over 2 times a sub 1, which is a negative 10, plus a sub 100 is a sub 1 plus 99 times 2. 198 minus 10, which is 188. And of course you could work that out. That's 50 times 178. That is 40, 35, 39, 5, 8900. Again, use a calculator for that. Do not do what I'm doing. If I want to add those, well, n equals 0, you get n equals 0, you will get a 2, n equal 1, n equal 2, n equal 3, and n equal 25. Negative 75 plus 3 is 73. So this is, now here's the catch. If I say start counting, you start with 1, 2, 3, 4. Right? So if I say count to 25, that's 25 numbers. Do you see that you're starting with 0? So these are actually 26 terms. So I could say, since this is arithmetic, that is 26, that is 26 is 26 over 2 times a sub 1 plus a sub n. That'll do the trick. Or 26 divided by 2 times twice a sub 1 plus, what was the other formula? n minus 1 times d. n minus 1, that's 25, and the common difference in this case is a negative 3. So either of those will do. Either way, you will get 13 times 4 minus 75. 4 minus 75 is 71. And do you notice you're going to get a 71 there? And plug this in a calculator, and there it is. You can multiply by hand, and not recommended, highly not recommended. So here, I need to know how many terms we have. We know a sub 1, we know d, but we don't know what n is. So I don't know how many terms you take to get that, but I know this is arithmetic, so a sub n is a sub 1 plus n minus 1. The common difference, what are you adding every time? You see that you're adding a 2? Now I need to know how many terms would it take to reach 41. Divide by 2 both sides. So n is 24. This is a sub 24. So I could say this sum here equal n over 2 into a sub 1 plus a sub 24. That is, so I didn't need to do any of this work for a sub 1. I already knew, and a sub 20, but I didn't know what n is, and now I know it's 24. So that is 12 times 36, and let me finish those two. So that is 71 times 13, 321, 1732. That is negative 923. Again, use a calculator. And here, if I take 36 times 12, that is 12, 672, 632, 13. That would be 432. And that's pretty much it for this section.